and welcome. I'm Tommaso Ridani, and this is Story Scanner, the podcast based on the stories headlining Via Sarfatti 25, the magazine from Bocconi University, with analysis and insights from Bocconi professors and researchers on the big topics in business, management, data science and politics. In this episode, we take a look at the ever-growing frontier of the space economy. The space economy is defined by the OECD as the full range of activities and the use of resources that create value and benefits to human beings in the course of exploring, researching, understanding, managing and utilizing space. The first phase of the space economy was characterized by governmental space programs, and then by the satellite telecommunications markets. Over time, barriers to enter space have decreased. Public-private partnerships and the entry of private actors, especially from 2000 onwards, into the space sector were instrumental, and increasing levels of private funding, advances in technology, and growing public sector investments have fueled a liftoff of the sector. Today, the progress in artificial intelligence has allowed increasingly advanced activities from satellite signals and data, contributing to new economic activities. Furthermore, thanks to the introduction of small satellites, it was possible to reduce the cost of production and satellite services, while at the same time expanding the demand for them. Today, our daily life depends on one or more satellites, from the use of credit cards to a reliable power grid, a navigation and Earth observation service, and minute-by-minute weather updates. Spacecraft and space access costs have also declined, and significant progress have been made in the design and development of cost-effective launch vehicles, also by private companies, such as SpaceX owned by Elon Musk. And the development of reusable rockets could prove a further turning point. And these developments provide access to space for many small and medium-sized companies, as well as educational and research institutions. On the economic front, these developments have opened the road to a whole host of activities, such as the extraction of resources such as rare earths and platinum group metals from the moon and asteroids, known as space mining, the possibility of developing space-based solar power, the development of innovative space exploration and communications technologies, the further development of the sale of services deriving from satellite technology, and with visionaries also looking at a future of space tourism. The most significant short and medium-term opportunities may come from satellite broadband internet access, but space as an investment theme will impact a number of industries beyond aerospace and defense, IT hardware and telecoms. The space economy is thus expanding enormously, with the participation of an ever-increasing number of actors, and today stands at a value of about $400 billion, destined to become a trillion economy within a few years. Commercial applications hold the highest share of the turnover, around 2/3, although military and institutional orders still represent a significant share of the total profit. We are now joined by astrophysicist Simonetta Di Pippo, who a few months ago became the new director of the Space Economy Evolution Lab, C-Lab, the STA Bocconi laboratory founded in 2018 by Andrea Sommariva to study the economy of space and the economic repercussions of space activities. She previously served as director of the United Nations Office for Outer Space Affairs, as director of human space flight at the European Space Agency, and has been director of the Universe Observation at the Italian Space Agency, and has also led the Observatory for European Space Policy in Brussels. She is an academician of the International Academy of Astronautics and co-president of the World Economic Forum Global Future Council on Space. Why is the space and the space economy such a hot topic at the moment?
Space economy is defined as the value deriving from the activities in space and all the services and applications on Earth which use space-based data and infrastructures to improve the quality of life of all the citizens in the world. In other words, it means that without space, we cannot even think about living these very days, because space is really the backbone of all the economies currently in the world. In particular, if we look at the emerging and developing countries, this is even more true, because using space-based data and infrastructure, we can really help them to approach their socio-economic sustainable development in the right manner.
One key aspect of such interest, as you mentioned, is economic. From mining rare earth minerals to exploiting all the technological benefits that satellites can offer. Can you tell us some more?
Space economy is divided in two main components. One component is called upstream and is related to activities for satellites and launchers mainly, while the second component is so-called downstream and is the set of activities related to the use of space-based data and infrastructures for services and applications on Earth. At the same time, space economy is divided in other two blocks. One is space for space, which is related to the activities done in space for supporting space exploration in space. And for example, space mining, extraction of space resources is under this category. On the other side, we have the so-called space for Earth. Again, how to use space for improving the quality of life on Earth on a lot of different fields, from agriculture to biodiversity, from food and water security to management of disasters, from telesurgery to teleeducation, etc. This means that we have to look at the short, medium, and long-term benefits of space activities when we talk about space economy, which today is a sector which is valued around 450 on average billion US dollars. And this economy is supposed to become $1 trillion economy by 2040. There are a lot of different evaluations about that. The only data which is absolutely clear, the trend is astonishing. The percentage of increase every year about the value of space economy is per se really interesting. And in the last 15 years, we can count an increase of about 176% of the value of space economy. So this means that if we talk about space mining and the extraction of space resources, which is in the category space for space, in reality, there is also a side for it, which is more linked to space for Earth. Because as we know on Earth, we are running short of rare earths, minerals. And so going on an asteroid, being able to land on it, drilling the surface, extracting materials, and being able to bring back these metals will help humanity in the future, because this will really help to cover this shortfall in rare earths on Earth. Last but not least, technologies are there. We clearly have to develop a few more technologies, not so disruptive, in order to be able to do what I just mentioned, which means landing, drilling, and coming back. And for sure, there are a lot of activities in this field, both from governments and the private sector, because this is clearly one of the most interesting fields where space economy can really bloom.
But a key challenge in all this is preserving the sustainability of space's ecosystem. What are the key issues here?
In particular, the low Earth orbit, which means around 400 kilometers above our heads. The orbits there are really congested. And the reason is that even if in 2007, the so-called space debris mitigation guidelines have been approved, And all member states of the United Nations are following these rules in order to reduce and to mitigate the impact of the so-called space debris, so space junk. Still, we have a lot of satellites and a lot of non-functional objects in orbit, and this can create, already now, some potential issues for operations in orbit for satellites which are really key for conducting normal activities on Earth. I'm thinking about Earth observation satellites or even GNSS, Global Navigation Satellite Systems, which are the constellations that we use, for example, when we use our navigator on our car to go from point A to point B. We have currently 4 GNSS constellations in orbit. One is the American GPS, the second one is the European Galileo, then GLONASS, Russian Federation, and Beidou, the Chinese one. And already in this way, you can count hundreds of satellites. There are more than 8,000 satellites operational in orbit right now. And last year, we have managed to launch, even if it was in a pandemic situation, more than 2,000 satellites. And the reason is that there are a lot of mega constellations coming. One example is Starlink, developed by SpaceX. They have already 13,000 satellites approved, and a little bit more than 2,000 already in orbit. Then we have OneWeb, which is a constellation close to 1,000, and then Kuiper, which is the new constellation for internet broadband, which is getting close to 8,000 satellites already approved. And then we have also other countries ready to launch mega constellations for connecting the world, which means that in the near future, we will have thousands and thousands of satellites in low Earth orbit, which means that there is a need of regulating and coordinating space traffic. So this implies that we do need global governance. We do need an entity able to inform the various operators of potential collisions so that they can avoid collision with other satellites. And in a way, we do need to approve additional rules so that the new operators, the new actors, can really start their activities with a responsible behavior. This is absolutely key because space has to be considered as a global common, and we need to maintain the peaceful uses of outer space and preserve outer space and the space environment for future generations, if we really want to support the future through space economy and through the use of space. This means that there are a lot of activities in this direction. One of the things that I consider the most important right now is that the Secretary General of the UN, Antonio Guterres, presented his common agenda last year, where space is one of the key topics, and in particular, space traffic management and global governance. And there will be in September 2023, the Summit of the Future, where this will be debated by all member states of the United Nations, the 193 members. We do hope that this will help also the commercial operators to work better, because for a commercial operator, for a private operator, to preserve its assets in orbit, the operator needs to have the predictability of the orbits, so the safe, secure, and sustainable environment that we all look for. One thing that may be considered extremely important is the fact that when we have new players entering into the field, there is also the need of doing a little bit of training, a little bit of capacity building, because entering the space field is not as easy as it may sound, and launching objects in space is not as easy as it may sound. So following the rules, having a full picture of what is happening in space, so that this can help us preserving the long-term sustainability, this will really be key. And so we collectively here, also in Bocconi, are trying to push for this idea of having a multidimensional and interconnected and cross-cutting activities in the space field, supporting space economy for the future.
Considering these exciting opportunities and challenges, and the interest that space generates in the new generations, what are the key professional aspects to develop for a new generation of people working around and in the space economy?
We collectively, as humanity, have to deal with one big issue. We have to deal in reality with a lot of challenges, but one big issue is the so-called future of jobs. With the introduction of new frontier technologies like artificial intelligence, robotics, biotechnologies, you name them, in reality, we do need to reshape the workforce of the future. And space enters into this equation together with these new frontier technologies. Because on one side, we do need to integrate space knowledge. So knowledge related to science, to engineering, to all activities which are strictly space related. But at the same time, we need to learn about space law and policy, finance, economy, a lot of activities that are, or fields that are extremely important for the future workforce to have knowledge about. This means that there is a need for the future workforce, for the future leaders in this field in Italy, but not only, because this is an issue that all countries, in particular the spacefaring countries, but not only in the world, are really dealing with these very days. Because the blooming of the space economy sector and the space market in general will require more and more a lot of experts that currently are missing. This means that there is a lot to be done in this field, but it has to be done in a cross-cutting manner, because we cannot live anymore with experts, vertical experts, only in one field. I always make an example. If you are a scientist and you want to have your experiment flying to Mars, well, first of all, you have to prepare a proposal for example, a space agency, and then you have to do it in international cooperation, because each experiment is done by several teams in different places in the world. And then, yes, you need to know the science of the instrument you are proposing, but you need also to know a little bit about the engineering of the same experiment, the instrument, because then you have to extract data from it. And then on top, you have to prepare a proposal, which means that you have to deal with the management of the proposal and the management of the experiment when selected. So you need to have also experience in space law, because you have to follow certain rules and principles and guidelines. And then you need also to have a lot of information about how to deal with space-based data, so big data, and how to use these new frontier technologies in the best way possible. So you cannot be a scientist only. You need to have a very broad knowledge. And that's what we will try to do here in Bocconi. So trying to have School of Management here in Milan becoming the center of excellence for Italy, for Europe, and for the entire world with this new, very innovative approach. So we will try to create a network of experience, expertise, so that everything can be handled properly, being us the center of this expertise and this network. It's a challenge. It's something that has never been done. And so I hope that this will be very soon. Milan will be the light at the end of the tunnel for everyone in the world who really wants to work in this field in the future.
To give us some insight from a company working in the space economy field, we are now joined by Giovanni Sylos Labini, CEO of Planetek Italia. He has cooperated with NASA for its plan in geodesy and geophysics, worked at the Italian Space Agency, and was Italian representative at the European Space Agency for cooperation in Earth observation. Planetek specializes in geoinformatics, space solutions, and Earth science, and provides solutions to exploit the value of geospatial data, including satellite, aerial, and drone data processing, monitoring with satellite data of the Earth's surface, and the development of spatial data infrastructures. Planetek is a partner of Bocconi's Space Economy Evolution Lab. Why is observation of the Earth so important for the space economy?
Earth observation is an important part of space economy, even if today its value is a small percentage of the total value of space economy. Consider that the global value of Earth observation contribution to space economy is nowadays about 3 billion euros. But the interesting aspect at this share is growing very fast. We expect that about 2040, the global value of Earth observation contribution to space economy will be more than 10 times than what it is today. And in some way, this is only the head of an iceberg, because there is an avalanche contribution of data acquired by Earth observation satellite to what we call big data and Internet of Things. In the end, is a very important component of the global digital transition that we are living nowadays. It's important to consider that about 1/4 of this market will be in Europe. And so it's very important that our industry is in position to dominate this area locally, regionally, but also globally.
How can data from space help improve life on Earth?
Well, there is a statement that we cannot control what we cannot measure. And we see how important are the effects, for example, of climate change on our everyday life and in the end also on our economy. There is an emerging interest in taking care, even within the economy and the financial of different industries, what is their contribution to the climate change. Let's think about something like carbon credits, and also to evaluate what will be the impact on the economy of the climate change. These two things can be done globally only using satellite Earth observation. For sure, not only Earth observation data. Again, it's very important to look at the use of Earth observation data as part of the big data universe, but is the natural point of convergence of this kind of information about the status of the planet and the evolution of the climate. As an example, international financial institutions need to evaluate the impact of climate change on their investment worldwide. For us, it's normally usual have a look to data from national institute, like for example for Italy Istat, that give you idea of what is going on in terms of productivity, a variation of the GNP. But there are remote areas of the world where this is not so easy. And again, Earth observation in that case can be a valid contribution to estimate elements of GNP of a nation from from space.
I hope you enjoyed hearing about what's going on in the field of the space economy. You can read more about this topic and many others in the new issue of Via Sarfatti 25 magazine, with opinion, research and insights from Bocconi professors and researchers. I'm Tommaso Eridani, and I hope you'll join me again for the next episode of Story Scanner.